Hello everyone, I am Anshu Saini, mentee under the mentorship of Misty ma'am as part of the LFX Mentorship 2025. I have worked on the white paper titled as Guide to AI-based Mainframe Modernization Application. I will cover the motivation and problem statement that was targeted by our white paper, code transformation basics, then evaluation attributes, then framework design, that is the key aspect of our paper, then a demo of the framework, and finally the contribution that was made. So, as mainframes are powerful systems running mission critical workloads in banking, healthcare, defense, and beyond, but many organizations still rely on outdated legacy systems. These systems are expensive to maintain, inflexible, and face skill shortages in legacy languages like COBOL, PLI, etc. So integrating them with cloud or microservices is also a major challenge. Therefore, our goal is to build a structured quantitative framework to evaluate AI-based modernization tools. Now a question arises that why and what is the need for doing that? So the answer to that is very simple because the current tool comparison are mostly qualitative and vendor driven, making decisions subjective, inconsistent, and misaligned with enterprise priorities. So basically, organizations are not able to uh, correctly identify which AI-based tool they should choose for modernizing their mainframes. So the framework that we are proposing through this white paper will surely help them rank the tools based on their enterprise needs. This is how the flow goes when an AI tool is modernizing, or we can say transforming a code from a legacy language to a newer technology, to a newer language. So it follows three types of conversions on a larger scale. First one is syntactic conversion, which basically convert the code syntax automatically. Then semantic conversion, it understands and convert the code meaning. It basically refers to the functionality of code. And the final is behavioral refactoring, which is improving the code behavior automatically. So in this way, we can transform a legacy code into a modern cloud native code, or we can say to a newer language, which is scalable, agile, and integrated. Therefore, code transformation is the key aspect of mainframe modernization. So let's explore a little bit more about code transformation. So code transformation lies at the heart of mainframe modernization, as we just saw. So it basically refers to the automated or semi-automated conversion of legacy code into modern languages and frameworks. This can be syntactic, semantic, or behavioral, each preserving functionality in different ways while enabling better scalability and maintainability. Like here is an example of a COBOL code of a finance organization converted to the Java code. So this is basically a simple example that how the syntax and the semantic along with the behavioral aspects of the code are remaining same. Next we will cover the evaluation attributes. So to make the tool evaluation objective, we identified 7 key performance indicators and we divided them into 4 dimensions. First one is technical fit, which comprises of language support, IDE or CI/CD integration, and refactoring capability. The second dimension is quality and reliability of the tool. It basically focuses on automated testing and AI assistance and analytics provided by that particular tool. The third dimension is enterprise readiness, that how suitable the tool is for a particular enterprise. So it comprises of 3 aspects. One is security, compliance, and scalability. And the final is usability and cost, which basically comprises of the learning curve, licensing, and documentation. Basically, how easy the tool is learnable by a particular organization. These are the key performance indicators, the KPIs that we selected for building our framework and for tool evaluation. So first one is the language support. Second one is IDE or CI/CD integration of the AI tool. Safe refactoring and automated testing, security and compliance, scalability, cost and documentation, AI automation and debugging. So in our framework, as we will see in the next step, we will see that each KPI is being scored out of 10 for every tool, and it completely depends on how the organization is giving the weights and the raw score to the KPIs. We will see this in our framework. Now we are starting with the framework design. So our framework follows four simple steps. First one is define the raw KPI scores. As we just said in the previous slide, that each tool gets a raw score out of 10. Each KPI gets a raw score out of 10. After getting a score out of 10, we normalize the scale to ensure the fairness when KPIs differ in scale. So this is basically a simple mathematical formula that we are using to normalize the scores. Step 3 is to apply weights. This is very important for keeping the flexibility in our framework. We are letting the organization assign the weights to each KPI based on their organization needs. And finally, we compute the weighted score, and the outcome that we will see in the framework will be the ranking of the tools based on the assigned weights and the raw scores as given by the organization depending on their needs. Now let's jump onto the demo of the framework, that how our framework is working. So this is a very basic and first look of our evaluation framework. So here we have listed down all the KPIs from 1 to 7. These are the weights that we'll assign. This is the minimum and maximum score. This is basically the raw score of a particular tool. So here we are comparing two tools, tool A and tool B. So let's directly start. Suppose we are assigning the weights like 0.15 to KPI K1 language and compatibility, 0.1 to ID and CI/CD integration. Now these weights are completely flexible. The organization will assign these weights and also the raw score as per the performance of the tool, completely based on their priorities. So let's say we assign 0.2 to safety vectoring, security we again give 0.15, scalability we are keeping 0.15, cost and documentation we again give zero point 0.1, and AI and debugging part of that particular tool, like the value that AI and debugging KPI holds for that particular organization is say 0.15. Now let's come on to the raw score. So for tool A, suppose we give 7 here, 8 to this part, 6, 5 and 5 to scalability, 7 and 6. So we see that the normalized score as in the step 2 of our framework is being calculated, and then the total weighted score is computed. Now let's give raw score for tool B. Suppose it's performing better, so we give 9, 7 for ID and CI/CD integration part, 5 here, 4, 3, 7 and let's say 8. Yep. So now as we see that automatically all our calculations are being computed as per the formula specified by us. So we see that the ranking of the tools are being shown here. So rank A, rank 1 is given to tool A and rank 2 is given to tool B. So we clearly see that tool A is performing better for this particular organization and tool B is lagging. Now we can also see that by what factor and in what KPI the tool B is lagging by a column gap. So this column basically represents negative, indicates that tool B is performing better for this particular KPI, and we can also see here by the raw scores. And here gap is positive, which indicates that tool A is performing better than tool B. And this value represents by what factor either of the tool is leading the other two. So this is how the evaluation framework is very flexible, and it also provides great insights into not only the tool ranking but also the part where each tool is lagging and in what particular KPI. So it would be beneficial for the tool vendor to also assess the tool as per the organization in which it's lagging the other two. So let's come back to our presentation. Thank you for this. Yeah. So did you know that more than 70% of global banking transactions still run on mainframes? So modernization is not optional, it's critical. AI-based code transformation offers a faster, safer path forward in the journey of mainframe modernization, and so does our KPI-driven framework, ensures decisions are data-driven and aligned with enterprise strategy. Finally, I extend my heartfelt gratitude to my mentor, Misty for her invaluable guidance, to the advisors and experts for their support, and to the Linux Foundation for this opportunity to contribute to the future of mainframe modernization. Thank you.